Could we be on the verge of the biggest discovery in human history? What if I told you the signs of alien life aren't just in science fiction movies, but are being actively searched for right now across the vastness of space? From bizarre signals in distant galaxies to strange chemical signatures in our own cosmic backyard, the evidence is mounting. Forget little green men for a moment. The real story is far more fascinating. Let's explore the most compelling signs that we are not alone. Our first stop is right here in our solar system. For decades, Mars has been our prime suspect. We've sent rovers, orbiters, and landers, all hunting for one thing: water. Why? Because on Earth, where there's water, there's life. We've found frozen water at the poles and strong evidence of ancient rivers, lakes, and even oceans. But the most exciting discovery is the seasonal plumes of methane gas. On Earth, most methane is produced by living organisms. While geologic processes can also create it, the fluctuating levels on Mars are tantalizingly similar to biological cycles. Could tiny microbes be hibernating beneath the Martian soil, waking up when conditions are just right? The Perseverance rover is currently collecting samples that might one day give us the answer. But Mars isn't the only contender in our neighborhood. Let's travel further out, to the moons of Jupiter and Saturn. Europa, a moon of Jupiter, is a world encased in a thick shell of ice. But beneath that ice, scientists believe there's a vast global ocean of liquid salt water, possibly twice the volume of all of Earth's oceans combined. This ocean is kept liquid by the immense gravitational pull of Jupiter, which flexes and warms the moon's interior. Even more exciting, this process could create hydrothermal vents on the seafloor, just like the ones on Earth that teem with life, completely independent of sunlight. Imagine a dark underwater ecosystem thriving for billions of years. Then there's Enceladus, a tiny moon of Saturn. The Cassini spacecraft flew through massive plumes of water vapor, erupting from cracks in its icy surface, like a cosmic geyser. And when it analyzed this spray, it found not just water, but also silica, methane, and complex organic molecules, the very building blocks of life as we know it. These plumes are essentially free samples from a subsurface ocean, telling us that Enceladus has all the key ingredients for life: liquid water, an energy source, and the right chemical compounds. It's one of the most accessible places in the solar system to search for extraterrestrial organisms. Moving beyond our solar system, the search expands exponentially. Thanks to telescopes like Kepler and TESS, we've discovered thousands of exoplanets, planets orbiting other stars. Some of these are in the habitable zone, often called the Goldilocks zone. This is the sweet spot where the temperature is just right for liquid water to exist on a planet's surface. Not too hot, not too cold. Finding a rocky, Earth-sized planet in this zone is the first step. The TRAPPIST-1 system, for example, has at least 3 planets that fit this description, orbiting a small, cool star just 40 light-years away. That's practically our neighbor in cosmic terms. But finding a potentially habitable planet is just the beginning. The real trick is to look for biosignatures, chemical fingerprints of life in their atmospheres. Using powerful instruments like the James Webb Space Telescope, astronomers can analyze the light that passes through an exoplanet's atmosphere. They look for a specific cocktail of gases that would be hard to explain without biology. For example, finding large amounts of oxygen and methane together is a huge red flag for life. On their own, these gases quickly react and disappear. To have both in abundance suggests something is constantly replenishing them, and on Earth, that something is life. Photosynthesis produces oxygen, and microbes produce methane. Finding this combination on another world would be an absolute game changer. Now let's talk about something even more mind-bending: technosignatures. These aren't signs of simple microbial life, but of intelligent, technology-building civilizations. This is the realm of SETI, the search for extraterrestrial intelligence. For over 60 years, astronomers have been scanning the skies with radio telescopes, listening for signals that are clearly artificial and not from any known natural source. Think of a patterned, narrow-band signal that stands out against the random noise of the cosmos. One of the most famous examples was the WOW signal in 1977. A radio telescope detected a powerful 72-second burst of radio waves that perfectly matched the profile of a potential alien transmission. It was so striking that the astronomer who found it, Jerry Eman, circled it on the printout and wrote "Wow" next to it. To this day, the signal has never been detected again, and its origin remains a complete mystery. Was it a stray signal from a passing satellite? Or was it our one and only glimpse of an alien broadcast? We may never know. More recently, the focus has expanded. What if aliens don't use radio? Maybe they use powerful lasers for communication. Or maybe the most obvious sign of a civilization is its engineering. This leads to the concept of megastructures. An advanced civilization might need so much energy that it would build enormous structures to harness the power of its star, like a Dyson sphere, a hypothetical swarm of satellites completely surrounding a star to capture all its energy output. If such a structure existed, it would block the star's light in a very strange way, causing unusual dimming patterns. This is exactly what was observed with Tabby's star, which underwent bizarre, irregular dips in brightness that no natural phenomenon could easily explain. While the alien megastructure idea is a long shot, and dust is a more likely explanation, it forced us to think outside the box about what a technosignature could look like. But what if the signs are hidden in plain sight? Some scientists propose looking for industrial pollution in an exoplanet's atmosphere. Just as our own industries produce gases like chlorofluorocarbons, or CFCs, an alien civilization might do the same. These are artificial molecules that don't occur in nature, so detecting them would be an unambiguous sign of technology. It has a strange thought. Our first confirmation of alien life might come from spotting their smog. And we can't forget the phenomena we simply can't explain. Fast radio bursts, or FRBs, are incredibly powerful but millisecond-long blasts of radio waves from deep space. In a flash, they can release more energy than our sun does in an entire day. We've detected thousands of them, and while some seem to be one-off events, others repeat from the exact same location. We don't know what causes them. They could be from magnetars, a type of neutron star with an insane magnetic field, or they could be something far more exotic. While most scientists look for natural explanations, the possibility of them being an artificial power source or beacon can't be entirely dismissed until we know more. So from microbes on Mars to megastructures around distant stars, the search for alien life is a multifaceted scientific quest. It's not about waiting for a flying saucer to land. It's about careful observation, about pushing the limits of our technology, and about asking one of the most profound questions we can ask. Are we alone? Each new discovery, whether it's an organic molecule on a moon or a strange signal from the void, brings us one step closer to an answer. The universe is vast and full of wonders, and the possibility that life has arisen elsewhere is not just a fantasy, but a statistical likelihood. The search continues, and the next discovery could be just around the corner. Thanks for joining me on this cosmic journey. If you find this topic as fascinating as I do, make sure to like this video and subscribe for more deep dives into the mysteries of our universe. What do you think is the most compelling evidence for alien life? Let me know in the comments below. See you next time